Hello. On this video, we're going to be talking about piecewise functions. Now, a piecewise function is very similar to just a regularly defined function. The difference is that a piecewise function is defined differently on different subsets of its domain. Right? So think of those different definitions as being pieces and put in those different pieces on different x values. Right? So different intervals in which the function is defined. So that is all a piecewise function is. That's a definition, but it's easier to see if you just do a couple of examples. Right? So here I have an example of a piecewise function. And anytime you have a piecewise function, you want to write it like this. Right? So you have f of x equals, you do curly brackets, and then the first part you write is the actual function value. Okay, so this is saying that the function is equal to 0, right? And then comma, and then the next part is the domain on which this function is defined like this. Right? So this is let's call this part the piece, and this is the domain where the piece is located. So this is saying that for x less than 1, our function is defined as 0. Okay? And then you do the same for the other part. Right? This other part is saying that for x greater than or equal to 1, our function is defined as 2. Okay? And that's basically all it is. Right? You define the piece and on what domain it occurs, and you do that for how many different pieces you have. Right? In this case, we have 2 pieces, so we need 2 pieces and 2 domains. Okay? Now let me graph this one for you real quick. Other than that, the only thing you have to be careful of is, are you using just less than or greater than signs, or less than or equal to signs, and greater than or equal to signs? Right? That's the only other thing you have to be careful of when you graph these things. Okay? So let's say I want to graph this function. So I know that for x less than 1, our function is 0. Okay, so let me start always left to right. So the function is 0. So it's coming this way, this way. Now, what happens at x equals 1? Notice that x equals 1 is not included in this domain, right, for the first piece. Right? The domain of the first piece is only all real numbers less than 1, but not including 1. So instead of drawing a filled-in circle at x equals 1, since I'm not including it in this particular domain, or the domain of this piece, you use an open circle. And then as I mentioned before, since I didn't draw something like this, right, so if I drew something like this, then I would be saying that the line ends at that particular x value. If I don't draw something like that, then it's understood that this line is continuing to grow further and further away in the left direction. So you can do this, or draw an arrow. Just so we use as symbols, I like to just draw it like that for now. Now, so that's the first piece, and that's basically how you want to graph these things. Just do it piece by piece, always starting with the smallest x values and working towards the largest. So you always start working from the left of the graph towards the right of the graph. So now we move on to the second piece. For the second piece, our function is defined as just a function 2. So it's a horizontal line going through y equals 2. And it's defined like this for x greater than or equal to 1. So since in this case, 1 is in the domain of this piece, I'm actually going to plot it with a filled-in circle. Again, because x equals 1 is actually in the domain of this piece. And then we know it's just a horizontal line. And that's basically the only thing you have to be careful of. If the function or the domain value, the input value, or the endpoint of your interval, whichever way you want to think of it, is not in the domain of the current piece that you're working with, you draw an open circle wherever you have to. If that input is in the domain of the piece you're working on, then you do a filled-in circle. And that's basically how it goes. That's basically all. So let's just do another example. So graph the function given by f of x equals, again, let's do it piece by piece. So the first piece is the function defined as -2, so just a horizontal line going through y equals -2, on the domain -2 to 0, not including the endpoints. The next piece is from x equals 0 to 3, including 0, our function is defined as the line x minus 3. Right? We saw in previous videos how to graph these. And then for x greater than or equal to 3, our function is just a horizontal line going through y equals 5. So again, always start working from left to right. So smallest values of x, so largest negative values of x, working towards the largest positive values of x. Okay. So largest negative to largest positive. Okay. So working left to right, we're going to start first with this one. This corresponds to the smallest values of x. Okay. So on the interval -2 to 0, not including the endpoints, our function is defined as -2. Okay, so I go here, so I start here. Okay. Now, since x equals -2 is not in the domain of this piece, I draw the graph, but I do an open circle. Okay. So I do an open circle there, and then it's just the horizontal line y equals -2 until we reach x equals 0. Since I'm not including x equals 0 in the domain of this piece, I'm going to do an open circle there. Okay. So that's the first part. That one's done. Now let's move on to the second part. And again, I know that I'm not including those because there's no lines between underneath these symbols, right? They're just strictly greater or less than, not greater than or equal to, or less than or equal to. Okay. Now for the second piece, now I'm looking at x values between 0 and 3. And I know that the function is defined on this interval as y equals x minus 3. Okay. So just as review, we saw how this works. We're given a function like this. We know that the slope is 1 and that the y-intercept, or the place at which the, so b is -3, and that means that the place or the point at which this function crosses the y-axis is at the point 0, -3, 0, b, whatever b is. Okay. So I know that this function crosses the y-axis at 0, -3, and that happens at x equals 0. So I'm going to start here. Since 0 is included, right, because of the less than or equal to, I'm going to draw this circle with as a filled-in circle. So I have the point 0, -3. Since x equals 0 is included in the domain, we draw a closed circle. Now from that, afterwards, you just use the slope. So remember, I told you that you can, if you have a whole number like 1, you can always just write it as a fraction. It's whatever number you had over 1. And that the first one in the numerator is telling you the rise, which you always do first. So this is saying that you rise 1, and then you move 1 towards the right. Okay? So doing that, I move up 1, move 1 towards the right, and you connect the points. So basically, this is going to look like this. Now, since x equals 3 is not in the domain of this particular piece, when I reach that x value, I'm going to draw it as an open circle. And then finally, for the last piece, or the third piece, now our function is just a constant function 5, or a horizontal line through y equals 5, and we're including the x value x equals 3 in the domain. Right, so go to x equals 3, move up to 5. Since that input is in the domain, I plot it with an open circle, a filled-in circle, and then it's just a constant function 5. And again, in this case, it's understood that this line is continuing indefinitely because I don't draw an endpoint to it. This one here should be understood that it's not going out indefinitely because I do have endpoints there. Even though they're open circles, they still constitute as endpoints. And that's the idea. That's how you graph a piecewise function. You just do it step by step, moving left to right, graph the function or the piece that's given on each domain, and then just move on until you do all of the pieces. And again, the only other thing to be careful is if you're using just strict inequalities, so less than or greater than, draw your function, but at that x value, draw an open circle. Right? If you have a greater than or equal to or less than or equal to, graph your function, and at that input, do a filled-in circle. And that's basically it.